Hi guys, in this tutorial I would like to introduce you to LinuxCNC Feautres and its features. What is LinuxCNC Feautres? It's like a small native CAM for LinuxCNC to do some simple jobs right inside LinuxCNC without using any other CAMs. So, what can we do with LinuxCNC Feautres? What we got over here? Here we got a tree of the features which can combine inside each other. We can add new features over here or move them up, down, remove them. There it's renew or refresh button which will refresh the preview of our code. So, and we can do the after refreshing after each change in the parameters, like this. So, let's get started with the tutorial. What can we do right here? Let's move everything out and assume we are going to make a motor mount for some stepper motor. What should we do right now? Okay, let's fix it. First of all, we need to make 4 mounting holes, the center hole and the cutout of the plate. Okay, let's try to do it. Let's add a feature. For example, for a center hole, let's try to use an oval. It's like an ellipse or something like this, something between a rectangle and circle. This will allow us to mount our motor with some gaps and allow further adjustments. So let's make the center hole. We've had an oval. Let's think of the diameter. It's 38.1. Okay, diameter 38.1. The reason we add an oval instead of just a circle, because the oval can be easily turned into the circle. Just set the L to the 0 and it's a perfect circle. And if you adjust something like, I don't know, let's make it 20 millimeters of adjustments. So we got an oval. Then we need to make mounting holes. Okay, let's copy this oval and adjust the diameter. Okay, it's 5 millimeters. Yeah, we got one. So now we need to make 4 of these mounting holes. We can just copy and adjust centers of these ovals, but we got some easier way. We can add a feature which called circular array. So it will make an array with the circle of our features. Put our oval in the array. So change number to 4 holes. Got 4 holes, but they are rotated not in the correct way. So we just not to rotate our features while rotating the array. So next we need to change starting angle, because they should go in the other way. It should be 45 degrees. Pretty nice, looking like almost ready. One more thing, we need to adjust this diameter, the distance between the mounting holes. Right here we can see 46.1 or 47.1. Let's take the diameter. Usually it's made in diameter. Okay, it's 36 and boom, boom, boom. Okay, we got it, 36.6. So we add it in the array diameter, 6.60109. Yep, we've got something like this. Great. And let's add a final cutout. Rectangle from center. Let's make it something like 56.4 and height of 56.4. I can try to add an expression over here, plus 20 millimeters to adjustments. Yeah, it's worked. Strange thing, just try it for the first time. Okay, now we got the mounting hole, the mounting plate for the motor. Great start, but I think we can do something more interesting over here. Let's try to make a new feature or make a new import for this mounting hole. So let's add in a group, just a group to make them all together. Group. Okay, put everything into the group. Inside a group. Okay. Inside. Oops. All the items seems to be over here. Go back. It's a big one. Back. Yeah. So I got a group. Let's name it motor mount. So it's a kind of template, but it's only for the one size, the defined size over here. Let's do some kind of magic. So let's add some parameters for the motor mount, so we can do any motor mounts with the same feature. So add just arbitrary code feature over here, add it to the group. Let's define all the diameters and sizes into the parameters. So let's assume diameter, bigger diameter, 38.4, that's BD. Small hole diameters, D1, 5 millimeters. Adjustments, 20 millimeters, and total width on the plate. 36.4. Okay, so what we're going to do now, we will add all these parameters over here. So this will be width, and this one too. Width plus adjustments. And adjustments. Okay, skip everything else. This one is the bigger diameter. Come on, diameter, and this one. Okay, one more size we need to add. This is smaller diameter, and we need to add the diameter of the circular array. So let's add it over here, that Z2, make it 66.609. Need to place it over here. Let's check that everything works fine. For example, make an adjustment to 10. Not everything. We forgot to add adjustments to our ovals. Adjustments, okay, and to this one, adjustments. Yep, works. Okay, let's make a motor mount without an adjustment. 0. Perfect. 20, back to 20. Okay, we can try to change something like this. Okay, works. 30.8, I think. Okay, so what are we going to do right now? We're going to save this as a template. So put an save button. Save as. I got one. Motor mount. Let's be like this. Or maybe I can. 23. Okay. Saved it. So right now we can add this template. We just created. We got a template with all the adjustments, with everything we need right there. So we got a motor mount. As you can see, we got a multi-pass cutting over this mount. Oh, by the way, we should put our rectangle to the bottom because it will cut out all the plate. That would be at the end of the thing. So we can adjust the parameters of the depth on each pass, or for example final cutting or any others. So rapid distance. To do this, we just add an set cutting parameters feature. Put it at the top. For example, change the depth. Let it be 5. No, not 5, -5. Okay, here we go. We can change depth step, for example, to 3. Have just 2 steps, and the final cut is a small thing. We can change the surface height, for example 5. We'll add some more cut roads. So that is almost all I wanted to show you. Try Linux features by yourself, LinuxCNC features by yourself. Thank you for watching. Bye.